Hi class, so welcome to the part 2 of your video for this week, and we're going to talk about potential energy and energy conservation in this for the whole duration of this topic. Okay, so as I mentioned in the previous video, we already discussed about kinetic energy. So review lang natin. So kinetic energy, or KE for short, is equivalent to 4.5 mv squared. Right, 1/2 mv squared. So to check the unit, ano bang unit ng kinetic energy? So we have to go back to the dissected units. So mass is kilogram multiplied by m squared over v squared, since v squared yan. So we see here kilogram meter per second squared. So kilogram meter per second squared multiplied by meter, kasi may naiwan bang meter dahil dalawa yan. Okay, so we have Newton meter, or that is equivalent to joule. Alright, so hope that's clear now. So potential energy is the energy associated with position, configuration of bodies in the system. So the key word here is position. Okay, so potential energy depends on the position or configuration of the bodies in the system. So the forces that can be associated with potential energy are called conservative forces. So conservative siya kasi parang ano mo yun, parang conservative ako because I'm keeping my virginity until I get married. Parang ganun. So it's like that, you know. So, kinikip niya yung energy niya. So, that's why I call conservative forces. Because they keep their energy, and when you release it, they release their energy as well. So, there are two types of potential energy here. So, we have gravitational potential energy. So, from the word gravity, and we have elastic potential energy, which is already discussed. I think that's like spring, you know, elastic, because spring is elastic. It can be compressed, it can expand, you know. So so you have two potential energies. You have two kinds of potential energy. We have gravitational potential energy due to gravity, and then we have elastic, which is like spring. So let's talk about gravitational potential energy. So with the gravitational potential energy, it is associated with the body's weight and its height. Okay, so technically when we say weight, it's force, right? And when we say force, it is mass times acceleration. And when we talk about gravity here, it is acceleration due to gravity, kaya nagiging mg. But technically this becomes weight, or w. Okay, so so ito na nga, andito na nga, oh. So this means to say that the higher the height from the initial point, okay, the higher the potential energy. So take for example this one. So in this one, it has the highest potential energy here, and also here the potential energy will be based on not on the distance actually, but on the height. Okay, huwag kayo ma-confuse dyan. It is basically on the height. And for this one, yeah, still the same based on the height, which is 3 meters. So hindi natin kino-consider ito. We consider the displacement itself, or the shortest path to the ground. So the formula for the potential energy, or PE graph, is equivalent to the mass of the object multiplied by the gravitational constant g, which is equivalent to 9.81 meters per second squared, and then the height. So whatever that height is. So this is not a height. If you see it, this is not a height, but distance, this is the height. Okay? So hope that's clear now. So take a look, for example, this one. So potential energy changes for roller coaster. So 1,000 kilogram roller coaster car moves from point 1 here to baguhin ko lang yung kulay. Point 1 here to point 2. Okay. So, and then point 3. So, what is the gravitational potential energy at points 2 and 3 relative to point 1? Okay, that is take y is equal to 0 at point 1. So, it means to say, we say that this is 1 at 0. Okay. So, at this point, so we are talking about 10 meters of height. So, the PE, okay, so the potential energy of the car when it is here at the top, okay, PE at 2, that is equivalent to 1,000 multiplied by 9.81 times the height, which is 10. Okay, so basically that is 98,000. So the potential energy here is 98,100 joule. Okay, So letter B, what is the change in the potential energy? So box natin. So that's for letter A. Letter B, so what is the change in potential energy when the car moves from point 2 to point 3? Okay, what is the change? Okay, so what is the change in potential energy? So initially you have to, so lalaki pa to kasi lalaki pa to lalo kasi instead of having 10 you added 15. So technically speaking, ito yung magiging potential energy mo. Yun na yun, no? 98,100. So magdadagdag ka ulit ng another 15. So ano yung potential energy at point 2 and 3? So and 3. So that is 1,000 times G times 15. So the total itself, so what is the change in potential? That's not really a change. So when we say change, really, we are using point 1 as the reference point. So technically speaking, so yung magiging change natin na ito na lang. Yun lang natira eh. So that's 1,000, 9.81 times 15. So this is equivalent to 147,150 joule. Okay? So that is from point here to here, from 0. Okay, so that is the energy. Okay, so letter C, repeat parts A and B, but the reference point to be at point 3. Okay, so it says here that going to repeat A and B, but we're going to use the reference point y is equals to 0 to be at point 3. So obviously, okay, if we're going to take into consideration this one, the potential energy from this point to this point, okay, is not going to be 98,100 but the total of this one. So ito magiging total na. So ibig sabihin at when origin is at point 3, then immediately the potential energy at point 2 is equivalent to 1,000 times G multiplied by 25. Okay? Bakit? Because that is the total height. So you take into consideration the total height. So remember that in potential energy. So it's not the distance, but it is the height from the ground. So that is the total energy. So that is the potential energy uh, at point B. Okay? So that's 1,000 9.81 times 25. So the total is 200. Okay? So 245,250 joule. Okay? Okay, baba na ng Bitcoin. All right, so that is that's it. Now, that's at point at from this point to this point. Now the question is, what is the potential energy from point 2 to point 3? So when the object goes from point 2 to point 3, so what will be the potential energy of the okay? So this is a very tricky question. So what if the car is already here, or the roller coaster or car is already here at point 3? What is the potential energy? Okay, 1, 2, 3, 4, 5. Okay, the answer is 0. The answer is 0. Why? Because again, potential energy is dependent on the position. So when you are at ground level, your potential energy is 0. Okay? So at point 3, the potential energy is equivalent to 0. Okay? So hope that's clear now. Okay? So this is elastic potential energy, no? For example, yung kanina sa spring. Okay? So the potential energy associated with the body at touch on a stretch or compressed spring, which the force due to the spring is like this. So this is also potential energy, no? PE. So pero ang weird lang kasi nga kinetic energy ang work done pala dyan. Oh, sorry. Work done is 1/2 kx squared, no? So mamaya dadaan natin. Okay, so let's talk about this one. So we're done with potential energy, and now we're going to talk about mechanical energy. Okay, so mechanical energy, as it says here, it is the sum of kinetic and potential energy. So technically, PE plus KE. So that's the mechanical energy. Okay? So ito na nga. Yan ang formula. So, we say conservation of mechanical energy here because again, remember, energy is neither created nor destroyed but can be transformed from one form to another. So, when an object doesn't have a potential energy, it doesn't really mean that its mechanical energy is zero. No. Because there are times na meron siyang kinetic energy. Okay, mamaya, bigay ko sa inyo mamaya. Okay, ulitin ko. It doesn't really mean that when the object has zero potential energy, it already it means that the kinetic energy is zero. That is not always the case because there will be time that the object has zero potential energy but it has a high kinetic energy. So mamaya pakita ko sa inyo mamaya. So the conservation of mechanical energy shows here that when only internal forces and conservative forces do work on a system. So when the mechanical energy of system is conserved or constant. So it says here that the energy input is also equivalent to the energy output here. Okay, so mamaya, pakita ko sa inyo. So, going to look at this diagram, when the object is at its highest position, the potential, we only have potential energy here existing. So, it means to say that the mechanical energy here is equals to KE plus PE. Okay? But the question is, if the object is just hanging on this position, naka-stay lang siya dyan, does it have a kinetic energy? No. So, zero. So, obviously, at the highest peak of an object, kapag nasa rest siya, so it means to say that here, the mechanical energy is equivalent to the potential energy. Okay? Kasi wala tayong kinetic energy. Now, what if pinutol natin yung string? No? So, pinutol natin yung spring, so the conservative energy of this object becomes a kinetic energy. So, yun na nga, kinetic energy, tapos yung bumaba. So, it means to say that our potential energy is being converted to kinetic energy. But the question is, how do we compute that one? So, it's quite easy. Using this formula. Actually, using this formula. Okay? So, let's try an example for this one. So, this is the example. So, zoom in tayo. Zoom in tayong bagya. Tayo maka-zoom in. So, take for example, this one. This person at peak, the potential energy is 10,000. By the way, 10,000 joule. No? So, the kinetic energy is 0 because it did not move. So, at this point, okay, so nabawasan yung potential energy, na-convert siya into kinetic energy. And then at half or midway, 50-50 na sila. 50 potential energy, 50 kinetic energy. At this point, at 75% of the distance, 25, 75, and then here, the whole potential energy here is converted to kinetic energy. So, how do we compute for this one? Okay, so, map. Sa inyo. So, here, this is a formula. So, here, energy is equivalent to kinetic energy plus potential energy. Huwag kayo malilito. That is potential energy. Iba lang ang ginamit na letra. So, the formula is 1/2 mv squared plus mg. Huwag pansin yung y na yan. H, okay? So, technique for example, this one. So, balik tayo kanina sa 1,000. 1,000 joule yung PE, which is also equivalent at the highest point, okay? At the highest point. Let's say that the distance is 20 meters, no? So, at the highest point, which is at peak, the potential energy is 1,000 joule, which means to say that this is also equivalent to the mechanical energy. Okay? So, let's say na bumaba yung object, no? So, let's say na bumaba siya ng sabi natin 5 meters. Okay? So, the question is, at this point, what is PE and what is KE? Okay? You have any idea? Alright, so let's try to solve this one. So, again, as I said, the mechanical energy is maintained in this system. So, at this point, the mechanical energy is equivalent to 1,000 joule. Okay? So, we can find for the PE and KE. So, let's try to find PE. No, ilan kaya ang PE? So, when we say that the object lowered from this position, okay? So, we say that the object, let's say the object is, we can neglect the mass, no? Oh, no, we can't neglect the mass. Let's say that the object has a mass, let's say Um, mm, mm, wag na lang. Okay, walang mass. So, let's try PE is equals to mgh. Makakuha naman natin ng mass dyan eh. Actually, makakuha natin ng mass ng object dyan eh. So, when the PE is 1,000 and m and then 9.81 and then the height is 20 meters, technically, the mass of an object here, given in this scenario. So, hindi binigay ang mass dyan pero kayo magko-compute. Kasi pwede naman talaga makompute. So, paano pag gano'n ang ginawa, no? Biglang walang mass. Sir, paano i-compute, sir? Walang mass. Okay, so the mass of the object is, so it's 5.097 kilograms. Okay, so that's the mass of an object. So now that we know the mass of an object, we can know, okay, we can finally get it here. So that's 5.097 multiplied by 9.81, which is g, multiplied by h, which is, okay, so 20 minus 5, because that is already the height here, 15 meters, okay, plus ke. Okay, so ke is equivalent to 1000 minus this one, 5.097 times 9.81 times 15. So that's 750. So 750. Okay, so the ke or kinetic energy here is 1000, so it's gonna be 250. So let's say 250. So we have 250 joules here. So at this point, okay, bura ko lang. So at this point, okay, our our potential energy is equivalent to, um, technically it's, I don't know, one, so 750, obvious naman. So the potential energy is 750 joule and our kinetic energy is equivalent to 250. So total niyan obviously 1000. So the energy is conserved, 'di ba? Tama. So dapat equal 'yan ha. Yun ang pan-check dyan eh. Dapat equal. Okay, so that is at 15 meters above. Okay. So, what if may follow-up question si Sir Ical? The follow-up question is, what is the velocity of an object at this point? So, if the object came here at rest, and then what is the velocity of the object here? Okay. So, for that kind of question, you have two solutions. So, first solution is if you're going to, okay, okay example ah. First solution is going to use the formula of kinematics. And the second solution is using kinetic energy formula. So let's try using kinematics. So at kinematics, we can say here that the distance, or using the formula, h is equals to 1 half gt squared. Pas walang time, no? Okay, di pala pwede ito. Okay. Yung gamit natin formula is yung third equation, which is displacement, final squared equals to initial squared plus 2gh. Tama ba? Hanapin natin sa Google. Oops, excuse me. May na muna. So, kinematics formula. Alright, so tama formula. Final initial plus ax. Okay, so let's try again. So, that is the formula. So, at the final, we can calculate this one. Ito kasi hinahanap natin yung final. So, v squared is equals to initial, which is already equal to 0 kasi we started at rest. So, 0 plus 2 times 9.81 multiplied by height, which is, height is, ang binaba niya ay 5 wait lang, baka magkamali kayo at gamitin yung 15. No, 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 no. You don't going to do that because you are starting from this point to this point only. So, you're going to use 5. And then, basically, square root of 2, 9.81 times 5. So, the velocity at this point, okay, medyo amazing no, physics. So, that's 9.90. So, the velocity here is 9. Okay, wait lang, bura. So, the velocity here of the object the velocity of the object at this point is equivalent to 9, ang laki naman. Hindi pala lahat ng malaki maganda. Charot. 9 9.90 meters per second. Okay? So, ito yung dito using kinematics formula. So, let's try to use the formula using kinetic energy. Okay? Yung dito, tinuturo ko ngayon. So, we say that the kinetic energy is equivalent to 1/2 mv squared. Tama? So, kinetic energy that we have is 250. 1/2 mass is, what is the mass again? 5.097 v squared. So, the velocity equivalent velocity squared is 2 times 250 all over 5 point, ba yan? Kulang na ako. 5.097 na mass. So, ibig sabihin, is square root natin yan kasi squared ay v squared. So, square root na yan. Square root. Okay, so ano kaya? Anong lalabas? Magiging parehas ba? So, abangan ang susunod na kabanata. So, 5.097. Wow, amazeballs. So, ang velocity ay 9.90 o 4 meters per second. So, same lang, di ba? So, Sir Ikal, so pwede palang kinematics at saka kinetic energy. Pero, do you find it weird na merong difference between the two, pero para sila ng sagot? So, what's really interesting here is that kinematics, we don't really give about the mass of an object. We don't really care. We don't really care about the mass of an object. But in kinetic energy and energy, about energy, pag sinabi kasing energy, there will always be consideration of mass. Okay? So, so nevertheless, they arrive at the same idea or the same answer because they basically have the same guiding principle. So, yun lang din naman. So, did you know that the formula for kinematics was derived from the formula of mechanical energy and kinetic energy? So, kaya same lang sila. So, ang tanong nyo, nauna ba itong kinematics? Hindi. Nauna talaga itong kinetic energy. So, we started from here. So, anyway, yun lang naman. Magpapabibo lang si Sir Ikal. So, yun. Yun yung computation, no? So, you can calculate the potential energy and kinetic energy at different points here. So, obviously, at this point, at 0, at H is equals to 0, so, your kinetic energy is equivalent to the mechanical energy. Here, baliktad. Kasi ang potential energy mo dito ay 0 na. So, all of the potential energy at the highest peak will be converted to mechanical energy. So, technically speaking, if you ask me, Sir Ikal, what will be the kinetic energy at ground level? So, obviously, the answer for that is 1,000 joule. So, same lang din. So, at the highest peak, potential energy is 100%, mechanical energy is 0. At the lowest point, which is at the ground, the kinetic energy is the highest and the potential energy is 0. So, I hope nagigets nyo yung concept. So, let's try talking about another roller coaster problem, no? Okay. So, siguro bigay ko itong assignment sa inyo. Bigay ko lang assignment sa inyo. Para may gagawin naman kayo, huwag kayo magkumpyahan, mga hiniyupak kayo. So, so assignment ito assignment. Isa yung sulat. Assignment number 2. Okay. So, screenshot ko na lang. Wait lang, pause ko lang para hindi sayang time. Alright, so na-upload ko na. Tawa-tawa kayo dyan tawa-tawa kayo sa assignment nyo Okay, pero naging naging heart na. Pagtaka kayo mga batang hilig-hilig nyo mag-heart. Anyway, assignment number 2 nyo yan. Huwag kayong magdaya, mga nipak kayo. Solve nyo yan. Practice nyo naman. Gamitin nyo naman ng kahit 5% lang ng brain cells nyo. Puro kayo kopya Okay, so, now, sasabihin ko na sa inyo ngayon yung mga sekretong bagay. So, meron kasing kwento noong unang panahon si Galileo na may napansin siya. So, sabi niya, bakit? Ito, puna tayo Ano tayo ng picture. Chandeliers in huge Catholic churches. Uh, uh, yan. May napansin kasi si Galileo nung panahon noon. Sabi niya, so sabi niya, bakit yung mga chandelier, no? Kahit may malaki, maliit, pareho lang yung pag-swing nila. So, kahit malaki yung object at saka yung maliit, parehas sila ng pag-swing. Yun ang actually naging findings ni Galileo. So, gumawa siya ng experiment tungkol doon. And then, doon niya na-realize, doon niya nakita na, oo nga, walang kinalaman ng mass ng object sa pag-swing. So, kahit malaki or maliit man yung pendulum or yung nagsiswing, is parehas lang sila ng movement. No? So, so, para sa problem ng pendulum, so try natin tong ano PhET simulation, no. Okay, try natin yung PhET simulation. So, so dito natin mapapractice yung energy graph eh. So looking at this one, see at highest point, all right. So nakita niyo dito sa screen na to, di ba? At highest point, okay, the potential energy is at maximum and the total energy, which is mechanical energy, is also maximum, which is only equivalent to PE. Now, kung titingnan nyo kapag binabaan ko, okay, di ba, nababawasan din. Naman tanong, ano yung naiwan? Yun! Kinetic energy pala yun. Okay. Kinetic energy. Now, balikan natin yung pinag-usapan natin kanina tungkol sa mga paggalaw-galaw na yan. So, punta tayo sa period timer. So, ano yung period? Okay, tingnan natin na ang mass ng object natin is 1 kilogram. So, try natin ang period niya. Ano yung period? Period of oscillation, like they say. So, yung paggalaw niya. So, the period of oscillation, if we're going to note, is 1.7395. Okay, so pause natin. So, try natin liitan yung object. Sobrang liit. Okay, so try natin ulit. O, di ba? Pareho pa rin ang period. 1.7395. O, try natin lakihan. 1.5 kilograms. O, try natin ulit. O, di ba? Same pa rin. So, ibig sabihin, in pendulum problems, you don't really care about the mass of an object. So malaki man yan o maliit man yan, parehas lang kanilang period of oscillation o yung paggalaw. Still the same, no? So, may mga time na mabilis, may mga time na maikli. But the question is, Sir Rikal, yung period ba ay magiging parehas pa rin kapag yung length mo nagbago? Obviously, kapag mas mahaba yung length mo, mas matagal yung period mo. So, kanina, 1.7395, try natin. Mas haba yan, tatagal. O, di ba? Naging 2. So, kapag umikli naman yan, magiging mabilis din yan. O, di ba? Saglit lang. Okay? But it's still the same rate, no? Still the same mass. So, ilan ang point, no? So, pero balikan natin yung slide. So, here, okay. So, how do we compute the things here? So, medyo magulo, pero magiging madali yan. I-explain ko sa inyo. Okay. So, we are talking about mechanical energy here. And again, remember, potential energy is at maximum, that is also equivalent to the mechanical energy. Okay, so at max, at highest. So it means to say, sa pendulum problems, ang highest peak niya ay kung hanggang saan lang talaga yung itinaas niya. So, ibig sabihin, kung let's say ito na yung highest peak niya, okay, so yan yung height niya. Oh. At height, however, the height is given by the formula, this one. Okay, that is actually the formula. So, malalaman mo naman yung yung angle na yan kasi yan yung maximum niya So, titigil siya sa ganyan. Alam niyo yun. So, palikatin yung simulation Kung sinabi kong 40 degrees yan, yan lang talaga yung maximum niya. 40 degrees yan. Hindi na magbabago yan. So, ibig sabihin, yan na yung magiging angle mo, 40 degrees. Okay, nasundan. Okay. So, yung formula ng height, Kasi minsan kasi ang binibigay lang ay yung length ng string which is L. Okay, makinig kayo ha. Binibigay lang kasi talaga sa ganyan ay yung length ng string. Okay. So, ibig sabihin, at this point, at this lowest point, yan yung equivalent ng length ng string. Pero may mga times kasi na kailangan mong malaman yung peak ng, yung highest peak ng object mo. So, ibig sabihin, yung height na gagamitin mo dyan ay hindi yung length ng cable or ng wire, kundi ito. Yan ang gagamitin. So, ayoko nang ulitin. Ulit na ako. Okay? So, the formula here is, okay. So, ito na lang. I-analyze natin itong pendulum na to. Analyze lang natin. Okay? So, let's try. So, at this maximum point, so, ibig sabihin, ang may mechanical energy dyan, okay, sulat ko muna ang formula. So, at this point, okay, at this point, the mechanical energy here is equivalent to the potential energy, and that is equivalent to M G L minus L cosine theta. Okay? So, how about at this point? So, ano ang potential energy, ano ang kinetic energy? So, the answer is very simple, it's very direct. So, the kinetic energy here is equivalent to the mechanical energy, the total mechanical energy. Because the potential energy at that point is equivalent to 0. Okay? So, again, nasabi ko sa inyo kanina, there will be time na merong potential energy is equal to 0, but the kinetic energy is not 0. Okay? So, there are times na may mga problem na ganito, determine the velocity of the pendulum at the bottom. You know? O, diba? Determine the velocity of the pendulum at the bottom. Ba? Parang, paano yun? Paano yun, Zerikal? Okay? So, for example, okay? For example, this is part easy. Tulungan ko kayo. So, at this point, let's say na ang object natin is, let's say ang object natin is, um, okay, let's say ang ating mass dyan ay 1 kilogram. No, 1 kilogram mass. So, at this highest point, let's say that the length of the cable is 5 meters. No? So, it means to say that the mechanical energy, which is also equivalent to the potential energy at this point, is 1 multiplied by the G multiplied by 5 minus 5 cosine. Okay, the question is, ilan yung angle? Okay, ilan yung angle? Tayo na magsiset siguro for this now, for this time. Tayo na magsiset kasi tayo naman talaga ang humihila ng pendulum eh. So tayo na lang magsiset. Na-get nyo ba? Set natin na, sabihin natin na 40 degrees. Okay? 40 degrees. Okay? So, what is the potential energy, mechanical energy at this point? So, that is equivalent to 1 times 9.81 times 5 minus 5 cosine 45. So, the answer is, the potential energy at this point is 11.48 joules. Okay? So, question is, what will be the velocity of the pendulum at this point? So, it's quite easy. So, we can answer this one by using this formula. So, the kinetic energy here is also equivalent to the highest peak of the pendulum, which is 11.48. It's equivalent to 1/2. The mass is 1 mv squared. So, v squared. So, the velocity is equivalent to the square root of 2 multiplied by 11.48. Okay? So, that is the velocity. So, the velocity of the pendulum at this point is equivalent to 2 square root of 2 times 11.48. So, that's the velocity. The velocity is 4.79 meters per second. Okay. So, at obviously, kapag dito, papunta siya dito, parehas lang din naman sila ng potential energy dyan. So, it's the same. really, really the same. So, there's no problem. So, actually, madali lang tong problem na to if you're going to really master mechanical energy, which is quite simple. So, sana, i-practice nyo i-practice nyo to, no? Sana i-practice nyo talaga. Sana lang, sana. Okay? Oh, right, so spring. Okay. Okay, so ano ba? Skip na natin yan. So, quiz? Wow, may quiz. Okay, hindi ko na i-quiz ito. Gawin ko na assignment number 3. So, another assignment. No? Gawin ko na yung quiz na yan. So, gawin natin yung assignment number 3 yan. Kasi madaya si Sir Ikan eh. Yung mga text. Bakit ganyan yan? Okay, don't care. Okay, so, assignment number 3. Yes! Assignment number 3 na. Amaze balls. Send ko na sa inyo mga bata. Yan. Saya, ano? Okay. So, uy, meron pa ulit. Assignment ulit. Joke lang. Di na yan. Okay, pa-exam ko na lang yan. Okay, so, I guess that's it for the mechanical energy, no? Balikan natin to. Hindi ako makapahinga eh, pag ganito. You all know that the force here, okay, so try natin. Force. 1/2 kx squared. No. Tapos here, we remember that the force here, okay, so the object, medyo mahirap, ano? So, imagine natin ang initial point as, 0. So, tama. So, what will be the height of the ball? Ah. Try natin sa internet, no? Spring. Okay, anong formula? Motion of a mass on a spring. Wala kasi sa ano eh. Wala kasi sa ganito. Wala sa simulation. Okay. So, nangyari pala dito, so yung force na may apply mo dito, yun din naman ang force na itataas niyang bola papunta sa taas. Okay, so okay. Okay. So if you compress the spring like this, for example, if you compress the spring at 5 cm, no, compress the spring at 5 cm, so that's the force equivalent to 1/2 k 0.05 squared. So let's say that the spring constant of this one is, let's say, yung dati 2,000, F is equals to 1,000, 1/2 2,000 times 0.05 squared. So that's basically equivalent to 2.5 newtons. Okay? So that's the force spring. Tapos ibubulusok na pataas yung object. Oh, what will be the height of the ball? So at this point, the potential energy, okay, so at this point, Newton, force yan eh. Newton meter. How do we calculate this one? Meron kasing kinetic energy to eh, tataas eh. So KE is equivalent to 1 half mv squared. This has potential energy, then going up, kinetic energy from 0. So at highest peak here, but the question really here is how high the ball will jump, no? Hmm. Hmm. Okay, hanapin natin sa internet. Ito, K1 mv squared, PE, ayun, PE of the spring, 1 half kx squared. Hmm. Ano ba yan? Hindi pala force yan. Hindi man na-correct kanina. Work pala yan. Work? Ano ba yan? Work pala yan. Hindi pala Newton yan. Ano ba yan, Sir Ikan? Hindi mo man lang chinecheck. Joule pala ito. And that's also equivalent pala sa PE. Ooh, amazeballs. Okay. So, potential energy that is being converted to kinetic energy. Oh, so 2.5 joule is equals to 1 half mv squared. But you're talking about the height, really. So, hmm. So that potential energy can also be attributed to its kinetic energy. Kasi, in the first place, no, kapag ibabaon natin, ipipress natin yan, technically, hindi siya potential energy kasi meron siyang force eh. Talagang kapag binitawan mo kasi, magpipitik siya, di ba? So, hindi siya potential energy. So, kinetic energy siya. Tapos, aalamin mo yung maximum peak niya. Okay, nagets ko na. Okay, nagets sa Sir Ikal. So, at this point, you don't have potential energy, but you have instead kinetic energy. So, the kinetic energy here is given by this formula. Technically, ito rin naman yon. So, potential energy siya, pero hindi siya potential energy kapag dating dito. Kinetic energy siya kasi pipitik siya. Alam mo yun? So, parang ganun. So, magiging 2.5 is equivalent to mgh. Kasi kukunin natin yung height eh. So, magiging h is equals to the mass of an object. Let's say the mass is 1 kilogram, or let's say, 1 kilogram. So, 1 kilogram times 9.81. Okay, divided by 2.5. Therefore, the height, okay, assuming that the height of the mass of this ball is 1 kilogram, okay, so the height will be 9.81 divided by 2.5. So the height will be 3 meters. 3 point, wait lang, meters. Meters. Yeah, meters. 3.924 meters. Hmm. Wow, so ibig sabihin maganda tong spring na to. Malakas tong spring na to. So, okay, i-explain ko lang sa inyo guys kung ano nangyari. So, kung i-imagine niyo no, itong spring ipipress natin. So, meron siyang potential energy na hindi naman talaga siya potential energy to begin with kasi kinetic energy siya kasi gagalaw siya eh. I mean, regardless. Ibig ko sabihin is kapag binitawan mo yung kamay mo, pipitik siya. So, para siyang potential energy pero kinetic energy siya kasi gagalaw yung gagalaw siya eh. So, parang ganun. So, pero potential energy siya. Potential energy siya na kasi nakastore siya sa spring. Kapag binitawan mo, pipitik siya. So, for example, okay, so gawa natin ng panibagong idea, panibagong paradigm ha. So, ano ba yung sinasabi ni Sir Ikan? Kapag binaliktad kasi natin yan, wuk, O, 'di ba? Parang nangyari, potential energy yan, mahuhulog yan pababa, bubulusok pababa due to gravity. But in this case, hindi siya gravity, kundi mismong energy ng spring. So, tama yung assumptions natin. Okay, so dapat pala baguhin lang natin minsan yung paradigm natin, no? Para maintindihan talaga natin. So, ganun. So, ayun na, nag-guess ko na. Ngayon ko lang inaral. Okay. So, yun yung idea. So, all you have is kinetic energy. So, technically speaking, you have energy to push the ball upwards. So, now the question is, nakadepende yung height. Nakadepende ba yung height sa bigat ng object na to? Yes. Kasi, kung sobrang bigat naman ng object mo na yan, kahit hindi tataas yan, hindi yan tataas, no? Alam mo yung kapag yung spring nyo is pinpress nyo yan, tapos yung object nyo mas mabigat kaysa sa capacity ng spring, hindi tatalon yung object nyo. No? Nagigets nyo ba yung point? So, for example, para kayong kumuha ng spring ng laruan, tapos inapakan nyo, tapos ine-expect nyo ba na kapag kinompress nyo yung spring, ipipitik kayo pataas? Obviously, hindi, di ba? So, nakadepende yan sa spring constant K and then the mass of the object. Kaya nga meron pa tayong ginagamit na mass dito. Kasi nga, nakadepende ang magiging height ng pitik sa mass ng object. At dun sa magiging kinetic energy niya na nakadepende naman sa spring constant. Kasi kung pangit yung spring constant mo, for example, ang spring constant mo ay 100 lang, imagine niyo. So, the work done is 1/2, 100. So, ibig sabihin, 100 Newton per meter. Then, multiplied by 0.05. Okay, squared. O, let's say, lakihan na lang natin. Sabihin na natin, dahil malambot yung spring, naging ano siya, 0.5. Okay, squared. So, ilan yung weight? Ilan yung PE, potential energy? Ba, lumaki. Ibig sabihin, yung sobrang ano naman, sobrang compressed siya. Okay, mali naman ako. Retain na lang natin. Retain na lang natin. Ibig sabihin, pumangit yung spring kasi 100 na lang. Ibig sabihin, naging maliit yung spring or naging manipis. China quality, ganun. 1/2 0.05 squared. Imagine niyo ang potential energy na lang, kapag numipis yung spring nyo, kapag naging pangit yung spring nyo, magiging 0.125 joules na lang. So, kapag salpak natin yan dito, okay, pag pinasok natin yan dito, class, 0.125, okay, assuming na 1 kilogram pa rin, so, diba? Lobo ako. Diba? So, ang tanong, tataas pa yung spring? Ay tataas pa ba yung object mo na 1 kilogram? Uy, bakit tataas pa? Ano bang klaseng spring yan? So, ibig sabihin yung spring na yun, mas maano siya? Mas elastic siya. Ano ba yan? Sir Ikal? Ibig sabihin mas elastic siya. Ganun pala yun. Mas malambot. Ano ba yan? Mas malambot. Ibig sabihin mas naging pitik siya. Mas naging maganda yung pitik. Okay. I get it. Okay. So, ito pala yung spring na sobrang ganda, no? Yung tipong parang, ano siya, malambot siya na mapitik. Di ba pag mapitik yung lastik ko, masakit. Diba? Pag hindi naman hindi siya stretchable, no? Hindi rin siya masakit. So, ito pala, kapag tumataas pala yung value ng K mo, nagiging malutong. Okay? Nagiging malutong pala. So, kapag tumataas yung K mo, nagiging malutong or makunat, no? Makunat. Tapos kapag bumababa naman pala ang K, nagiging parang springy. Nagiging parang ano siya, elastic. Okay. Okay, I get it. Kaya pala tumaas. Okay. So, tama assumptions. So, tama to idea na to. Alright. So, tama tayo sa idea na yun. Tama tayo dyan. Okay. Now, last topic, no? So, as I promised. So, momentum. So, Okay, so crash course tayo sa momentum. Yan na ba tayo? Oh, mag 1 hour na tayo. So, 1 hour ulit. So, momentum. Momentum. Okay, so, momentum and impulse and collision. So, actually, masyadong ano lang, masyadong, para magkapatid ito eh, itong momentum at saka impulse. Para magkapatid lang yan. Si momentum at si impulse. May pakita ko sa inyo. So, kung sino man ang mga nanonood ng billiard dito, parang momentum impulse ko, ayan, mga ganyan. So, hanap tayo sa, ano no, sa pet simulation, baka meron. Baka merong collision. Try natin. Collision. So, kung nahirapan kayo, ayan. Collision slab. Okay, try natin. Ano ba yan? Ano ba yan? Bakit? Ala? Oh no! Aro. Never mind. Ayaw. Kailangan ng mga chuchu bla bla. Okay, diretso na tayo. So, momentum in classical mechanics is the product of mass and velocity. So, yun lang. P is equals to mv. Remember that. Actually, ito lang naalala ko ng formula nung high school ako. P is equals to mv. So, the SI unit of momentum is kilogram meter per second. So, wala nang ibang itsura yan ha. Kilogram meter per second. So, huwag kayong mako-confuse sa kilogram meter per second squared. Ibang usapan yun. So, momentum is a vector quantity kasi may direction siya. Again, velocity is a vector quantity. So, momentum is proportional to the amount of force needed to stop a moving particle. Okay, so na-topic na natin, di ba? So, sabi noon, force makes object move and force can also be used to stop an object. So, yun yung idea dito. So, parang for example, mayroon papuntang train, may bus na lang, bus, tapos ikaw yan, tapos may kapa ka kasi ikaw si Superman, tapos sabihin mo, stop, 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 tapos padiretso siya dito, di ba? Tapos sasalubungin mo, tapos ipapastop mo yung bus. So, dito yun. Nandito yun. Nasa tamang lugar kayo kung gusto nyo malaman kung anong susunod na pangyayari dyan. Okay, so tuturo ko sa inyo yun. So, the higher the momentum, the higher the force is needed. So, okay, the question is, how do we define momentum? Okay? So, momentum of an object is defined by its mass and its velocity. Okay? So, for example, if this bus has, malaki yung mass niya, kasi bus yan eh. Tapos, may mga sakay pang tao yan. So, let's say na ang momentum niya ay, mass niya is 1,000 kilogram. No? So, tapos ikaw, 58 kilograms. No? Tapos, gumagalaw ito ng 40. Abay, matindi. So, ano yung mangyayari kay Superman? Ano mangyayari kay Superman kapag yung bus tumatakbo ng 40 tapos ang bigat niya 1,000 kilogramo, no? So ilan dapat yung force ni Superman para i-stop yan? So para ganun. No? So malalaman natin using this formula. Okay? So the total momentum of a system of particles, or the momentum rho, not really P, but rho of any particle is equal to the vector sum of the momenta. Ganun. So, wala naman, hindi naman siya naintindihin yan eh. But we're only going to focus on this one. Momentum and its relation to force. So, the second law of motion here states that the force is equivalent to the mass times the acceleration of a particle, or the force net is equivalent to the change in the total momentum divided by time. So, the rate of change of momentum of the body is equal to the net force applied to it. So, ulitin ko lang. The change in momentum of a body is equal to the net force applied to it. This is pretty obvious naman. Okay. Alright. So, that's momentum, no? So, calculate the momentum. Okay, calculate natin ang momentum nito. So, the momentum of this bus is equivalent to 1,000 multiplied by 40 kilometers per hour. So, baguhin natin yung 40 kilometers per hour. Convert natin yung sa meters per second. Okay, convert natin. So, ayusin ko na lang. Kalat ni Sir Ikal mag-solve. So, 40 km per hour. So, in 1 hour, ilan tayo? In 1 hour, meron tayong 60 minutes. And in 1 minute, we have 60 seconds. Tapos, in 1 kilometer, we have 1,000 meters. So, cancel. Cancel. Walang cancel sa S. Parang siya nga si Sir Ikal mag-solve, no? Pero ganyan talaga, para sigurado ako. So may iwan na lang ay seconds and meter. So, meter per second, tama? So, that's basically 60 times 60 is 3,600. So, 40 times 1,000 divided by 3,600. So, that is basically 11.11. 11.11 meters per second. So, yan yung velocity ko. So, bura natin to. So, bura. So, magiging 11.11 meters per second. So, ang momentum ng bus is magiging 1, 2, 3. 1, 2, 3. Tama? 1, 2, 3. So, magiging 11. So, 11,110. Sulat, ayusin ko lang sulat ng pangit. So, this is 11,110 kilogram meter per second. So, that's the momentum of the bus. Now, we're going to take into consideration total momentum of the system of particles. Now, we have two objects. We have the bus and Superman. And again, the mass of Superman is 58 kilograms. The question is, what must be the momentum of what must be the momentum of Superman in order to stop this object? Okay, not really momentum, but the force, no? Yeah, the force, really, it's the force. Yeah, momentum na lang. Either way, we have mass. So, let's say na lumilipad si Superman, no, tapos didiretso niya, tapos babanggay niya yung bus. Yung dapat mag-stop silang dalawa, ha? So, what will be the velocity of Superman? So, okay, so momentum is mv. Remember? Thus, if the momentum of the bus is 11,110, the mass of Superman is 58 kilograms, therefore your velocity is equivalent to 11,110 divided by 58 kilograms, and that velocity is equivalent to wait lang, tama ba? The answer is 191.6 meters per second. So, ibig sabihin, dapat yan ang bilis ni Superman para ma-stop niya yung bus. So, pag nag-clash silang dalawa, biglang stop. Alam mo yun? Mag-stop silang dalawa, mag-stop itong bus. So, ganun. Yun lang naman ang idea. It's quite simple. No, ganun lang. So, wala masyadong topic dyan. So, for impulse, again, pero ano yung difference ng momentum and impulse? So, momentum kasi is, sa momentum kasi, we are saying that the object has a big momentum if it has big mass. Now, in impulse, the impulse is high if the time is low. So, ibig sabihin, impulse siya kapag very low yung time, which is mabilis. Diba? Pansin nyo to. Small yung time, oh. Small yung time, ang laki ng force, malaki yung impact, malaki yung impulse. Saglit lang eh. Pero ito matagal, mabagal, oh, mabagal. So, ibig sabihin hindi nagragasa yan. Parang ganun. So, ito saglit lang, short time, wasak. So, yun lang naman. So, the formula is I is equals to F times time. Technically speaking, impulse is also equivalent to momentum in terms of formula. Wait lang. In terms of, yeah. So, same lang naman sila. Now, to check if they're really the same, pakita ko sa inyo. Okay. So, again, the formula for momentum is P is equals to mv. Tama? So, the unit for this one is kilogram meters per second. So, the question is, since sinabi ni Sir Ikal na parehas lang ang impulse saka momentum, dapat parehas sila ng unit, tama? Now, if you're going to look at the formula here, force is kilogram, oh wait lang, force is Newton. But then, Newton is kilogram meter per second squared. Now, if you have time here, multiplied by second, so cancel yung second sa baba, so magiging kilogram meter per second. Wow! Amaze balls. Diba? So, ganun lang. So, parang same lang naman. So, that, hindi naman sila, yung ano lang, inuulit ko lang, ang distinct difference lang nila is yung paano nila tinitreat yung moment. Diba? Ito, tinitreat yung moment as its mass. Ito naman, yung time. Mapapansin nyo. Mapapansin nyo, diba, sa formula naman, merong time, oh. Dito naman, tinutukoy velocity and then mass. So, technically, parang velocity rin naman. Tutusin. Okay? So, I think that's it for impulse momentum, no? So, di na rin yan. Kung natin pag-usapan yan. So, di naman quite useful for that one. So, I guess that's is the point of this video. So, check ko na lang siguro kung ano pa yung natitirang topics, no? Check natin. Meron ba tayong collisions dito? Oh, goodness. Walang collisions. Yes. Okay. Siguro sa ibang topic na 'yon, baka sa dynamics na 'yon siguro, hindi sa physics na 211. So, sa ibang topic na siguro 'yon. So, I guess, magkikita lang tayo sa conservation. Yeah, ayan yun na yung conservation of momentum. Mm-mm. Yeah. Pero I really suggest na aralin nyo yan kasi magagamit yan eh. Pero siguro baka sa ano na lang, baka sa dynamics of rigid bodies na lang natin pag-usapan ng conservation of momentum and then collisions, no? So makita-kits na lang tayo doon. So I guess that's it for this video. So I hope na sagutan niyo yung assignments nyo diligently, no? So yung di naman tayo naglolokohan. Okay. So I guess that's it. Thank you. Bye-bye.